Everyone, good day to you, our dear students. How's everything over there? Today is another day to discuss about the new topic under the workshop practice course outline. So today we are going to treat about engineering materials. My name again is Dr. Rahim Isiaka Yobi of Physics Department of Physics, University of Lagos. Instructional objective. So at the end of this study session, students will be able to describe engineering materials, identify different types of engineering materials, understand applications of different engineering materials. Introduction. Religiously and historically, all living and non-living things are naturally created from materials called earth and will return to earth. Originally, most material exist in an impure state because they rate reactiveness with other elements. Selection of material depends on the professional factors and applications. So there's this aspect of a workshop practice which is called engineering material. You have been know about it briefly during your secondary school under the subject called introductory technology, which is now called basic technology. So they taught you engineering material briefly by introducing you to metal, plastic, ceramic, and others. So here, this is the application stage where you are going to use engineering material for the production of instructional materials. Let us look at the total material cycle. We have water cycle, we have oxygen cycle, we have everything cycle. So under the engineering material as well, we have engineering material cycle. So here is the heart cross. This is the heart. This is the heart where we are assisting. So from the heart core, there's extraction of ore, there's extraction of raw materials. After extraction of raw material, it go to the purification of material, distillation of material, extraction of material, purification of material, where all the raw undergo processing of removing impurity from purity. So purity form now go into referred to as raw material. We have iron raw material, we have coal raw material, we have oil raw materials, and as well. From this stage, it moves to another stage here. This is another stage for purification of engineering material, where more impurities are extracted. And from this stage, we move into another stage here that are referred to as bulk material. So from the bulk material here, you now have metal, we have ceramic, we have cement, we have paper, we have cement, and so on and so forth. So from here, it undergo another process. So if you go to market, you buy your sand, you buy your iron from Owodoni or anywhere they are selling metals, you buy your cement, you buy anything raw and a bulk material. Before you can use to produce anything, it has to undergo some processes. This is another process here. This is where you are going to turn your material into production something. You are going to produce it to make it useful object, which you are going to make at home. So here, the material that undergo the processes, when it got here, referred to as engineering materials. And from here, it go to the design, manufacturing at this stage. So when the product is produced for usage, it will now move to the municipal, to where we are going to use it for production of pole, for production of car, for bridges, for houses, for apparatus, for anything whatsoever. This is the stage where it goes. So when after production at this stage, it go to the end user, where we are making use of it. In your lab, you make use of the apparatus. After you've produced it from the production company or in the workshop, you take it here where you make use of it in the lab. This is the usage. This is where the end user make use of it. After you make use of it for many time, it's going to be reach the end of its life cycle. That is where we have the waste and junks. So the waste and junk you see here also can be recycled. Recycling of material don't go the recycle back to the bulk material. That is aluminum can that you see your environment, or the waste material picker in our environment. They used to pick waste to recycle it back to new bulk material. And as well, any material that can not be recycled, it go back, it decompose and go back to the heart. This is a complete total material cycle of engineering material, from the hull, go round and back to hull here. Any material that is not recyclable. But the one that is recyclable will go back to the bulk material and go back into the system. That is engineering total material cycle. Classification of engineering materials. Material can be classified according to engineering field. So material can be classified according to engineering field. So we have different engineering fields. So under the civil engineering, we have material that is commonly used there. We have stone, cement, lime, timbers. All these material are the engineering material that is peculiar to civil engineering. If you go to electrical electronic engineering, you also see conductor, insulator, and semiconductor. All these they are peculiar to electrical electronic engineering. And as well, let us go to mechanical. Under the mechanical, we have iron and steel, we have packing and lubricating materials. So all these materials, they are related to mechanical engineering. Let's take the material. The classification of material can be classified according to their types and composition as well. So according to their types and composition, here we have metal, we have polymer, we have ceramic, we have hybrid, we have semiconductor, we have biomaterials, we have advanced materials. All these materials, they are briefly introduced to you during your basic technology when you are still in JS classes. As well, property of engineering materials. The material have different properties, physical properties in terms of appearance, density, and availability, mechanical properties in terms of ductility, toughness, elastic limit, proportional limit, among others. Thermal properties, that is conductivity, diffusivity, expansion coefficient, shock resistance. And also chemical property, we talk about corrosion resistant, chemical composition, acidity, and alkalinity. Likewise, we have magnetic property of material, whereby you have paramagnetism, diamagnetism, and ferromagnetic. All these, they are properties of engineering materials. Description and sources of metals. So metal is engineering material which is commonly used at our home, for our home appliances, for our office as our appliances, at the laboratory as well. Majority of apparatus in physics department, they are produced from metal. So metal are classified into two, broadly classified into two. We have ferrous metal and non-ferrous metal. So any metal that have ferrous in its content, they are referred to as ferrous. But the one that doesn't have ferrous in its content, they are referred to as non-ferrous metal. So example of the ferrous metal is iron, because it contains Fe in its content, whereby example of non-ferrous metal is aluminum, copper, tin, lead. So all the ferrous metal, they do conduct. So they do magnetized. They can magnetize easily, but non-ferrous metal, there's no way it can be magnetized. That is one of the way you can distinguish between ferrous metal and non-ferrous metal. But if the aluminum contains iron in its content, will magnetize. It's no more pure aluminum. It's no more pure ferrous metal. This is the physical appearance of metal. Physical appearance, these are adamantine, brass, bronze, copper, electron, gold, this steel, silver, and platinum. This is the physical appearance of it. So you can distinguish between different metals from each other by their appearances. And type of metallic and material, these are all the materials, metallic material that we have. From the iron and steel, we have steel alloy that is used for strength critical applications. We have aluminum alloy are used because they are easy to form, readily available, expensive as well, and recyclable. Also, we have copper and copper alloy have a number of properties that make them useful, including electrical and thermal conductivities, high conductivities, and good resistant corrosion. Titanium, nickel, refractory material are used for high temperature applications. So they use refractory material to make oven and all the equipment that generates heat. So it have high temperature resistant than refractory material, whereby the nickel is alloy are used for still higher temperature. So uses of metal and its alloy, there are different usage of metals. Zinc metal, they are used for galvanizing iron, anti-corrosion, and they are used in the medical field and for medical applications. Iron is used as a construction material in bridges, houses, ships, and so on and so forth. So iron roofing sheets, iron spoon, iron fork, iron apparatus, they are there. And also tin is used for soldering, for preparing foil, for metal coating to prevent chemical action and corrosion, for panel lighting, and so on and so forth. Lead is used for making water pipe. In pigment is used in battery for making of battery and alloy. And titanium, extensive use in aircraft industries. So we have many other metals, but this one are mostly common use in our environment. And also we also have pure metal. We have mercury that you have in your thermometer. We have silver, gold, and platinum. And radioactive materials like uranium, plutonium are used in nuclear power plants to produce atomic energy via nuclear fusion. So all these, they are referred to as metals, its alloy, and their uses. Okay, let us meet in part 2 of the engineering materials. Thank you very much for listening to me. Thank you, and let us meet. Bye-bye.